Swayam Prabha. Digital India. Educated India.
So, last class I have solved one numerical problem to obtain the load settlement or load settlement behavior of the pile through analytical approach. Now, today or this lecture I will discuss that how we can determine the load carrying capacity of the pile by based on other approaches. So, as I discussed that we can conduct the plate load test, and that plate load test was the static plate load test, and where we increases the load with by steps continuously. But there is another plate load test that I have discussed, that is the vertical cyclic plate load test, where there will be loading, unloading and reloading. So, the purpose of conducting that vertical cyclic plate load test is that by conducting this plate load test, we can determine experimentally the tip resistance and the base resistance separately, because the static plate load test will give us the overall load carrying capacity of the pile, but by conducting vertical cyclic plate load test, we can separately determine the base resistance and the tip resistance. So, then we can use the dynamic pipe formula, by which also we can determine the load carrying capacity of the pile. So, there are number of such equations are given. Okay. So, I am discussing two of them. So, the one is the engineering news record formula or ENR formula, and basically here we are applied the hammer blow, because it is a driven piles, and we are applied the hammer blow, and that means we apply the energy, and so that means the work done we have to equate with the input energy. So, that will be that the W into H, that will be, because W is the weight of the hammer, H is the height of fall. So, that W into H will be equal to the load carrying capacity of the pile and the amount of the penetration or the deformation of the pile. So, that both are equated. So, we have, or these two equals value will give us that Q A, which is W H divided by the penetration, and if we apply the factor of safety, we will get the allowable load carrying capacity of the pile. So, where W is the weight of the hammer, H is the height of fall, and S dash is the theoretical set, which is S plus C. S is the real set per blow. That means, generally some say 10 blows, what is the total penetration, that is given, last 10 blows, what is the penetration. So, we have to determine the penetration for each blow. Okay. So, that is S, that means the penetration per blow, and C is the empirical factor. So, allowing the reduction in the theoretical set due to the energy loss, and F is the factor of safety. That means, if there is an energy loss, that is taken care by the C, which is a empirical factor. Generally, the factor of safety is taken as 6 here. Now, if there is a draw hammer, then the equation, this is the basic equation for different types of hammer, we can use this equation in different forms, and that is for the draw hammer, the single acting steam hammer, double acting steam hammer, these are the equations. And so, but here we have to use the proper unit. So, Q A is in kg, okay, and H is in centimeter, remember that. And here P is the effective area of the A is the effective area of the piston, okay, which is in centimeter. P is the mean effective stream pressure, which is kg per centimeter square. S is the final set in centimeter per blow. Okay. So, usually the average penetration for the last 5 blows of a drop hammer or 20 blows for a steam hammers are taken, as I have mentioned, that the last few blows average we have to take. So, that means the average penetration last 5 blows. Suppose last 5 blow average penetration is 10, last 5 blows average penetration is 10 millimeter. So, per blow penetration will be 20 millimeter or 20 centimeter. Okay. So, if the 5 blows penetration is 10 centimeter, then it will be 20 centimeter for per blow, or if it is 10 millimeter, then it will be 2 millimeter per blow. So, this way we have to calculate. So, this way we can determine the allowable load carrying capacity of the pile. Similarly, there is a modified Healy formula is given, where also actual energy is equal to energy used and energy lost, because in previous also equation also energy lost is taken care by this empirical factor C, but here the total delivered energy is energy used plus the energy loss. Okay. And based on that determine the ultimate load carrying capacity of the pile. So, again here W and H are the weight of the pile and the height of fall respectively. Then the factor of safety here we have to apply 2.5, and then eta is the efficiency, and that I will discuss how we can calculate the eta. Eta H is hammer efficiency, and eta is the efficiency of blows that represent the ratio of energy after impact of striking energy of ram. So, these two are the efficiency, and S is the final set, and C is the total elastic compression. So, elastic compression, so that is C 1, C 2, C 3. So, that means C 1, C 2, C 3, S is the final set, and then 2 eta each and eta, both those are the efficiency. So, this way we can determine the eta. So, this is if your P is the weight of the pile, I mean total weight of the pile, including the weight of the pile, then helmet, because we have to apply the helmet when you apply the blow. So, including all the, this is the weight of the pile and this is in tons. Okay. E is the efficient of restitution of material under impact and ranges from 0 to 5, 0 to 1 we can take an average value of 0.5. So, now if W is greater than P into E, then you have to use this equation, and if W is less than P into E, then you have to use this equation. Okay. So, this way we can calculate the eta, and C1 and C2 and C3 we can calculate by using these equations. I am coming back, but the eta H we can calculate from this table for drop hammer, single acting hammer, double acting hammer, diesel hammer. This is the eta H value. And C1, C2, C3. So, C1 is the temporally elastic compression of dolly and the packing. So, the compression of the pile, compression of the soil and the compression of the other components. Okay. So, that summation is C actually. So, C2 is the compression of the pile or pile material, elastic, all the elastic compression. C3 is the elastic compression or temporary compression of the soil, and then this is the compression of dolly and the packing. So, this way we can determine that the different, if the cushion is on the pile head and which is 2.5 centimeter, then we use this equation. And if the cushion is 7.5 centimeter, then you have to use this equation. And then this is the equation for pile compression, this is the equation for the soil compression. And so, L is the length of the pile in meter, area is in centimeter, because these empirical equations you have to use the proper unit. So, this is centimeter square, this is meter, this is centimeter square. So, here also this is centimeter, this is centimeter. So, that you have to apply here. So, remember that when you apply, there is a QU and there we have to actually you have to calculate the QU. So, both sides there will be QU. So, this will be a trial and error process by which we can determine the QU. So, that means once you calculate the QU, then you apply the factor of safety of 2.5, you will get the allowable load carrying capacity of the pile. Then we can determine the load carrying capacity of the pile by using the penetration test data. That means by using cone penetration resistance. By cone penetration resistance, if we take the average of 1D below the pile tip and 3D above the pile tip, total 4D, D is the diameter of the pile, zone average QC, that means the cone resistance, that will give us the tip resistance of the driven pile. Clear? I mean the average of 3D plus 1D, 1D below the tip and 3D above the tip. So, this average of 4D will give the static cone resistance. That means that we have to do the static cone penetration test. So, the static cone resistance QC, average QC will give you the driven pile tip resistance. Similarly, for displacement piles, what is displacement pile? I have discussed the displacement piles. Driven piles are displacement piles, where the piles are displaced laterally. So, for driven piles, the friction resistance will be average QC along the length of the pile divided by 2 in kilonewton per meter square, but this is limited to 100 kilonewton per meter square. And for each pile, this is QC divided by 4 limited to 50 kilonewton per meter square. And remember that the average field value of cone penetration resistance is kg per centimeter square over the pile length. Okay. So, these unit you have to use properly. Okay. So, because these are empirical equations, so that you have to use properly. So, then by using N value also we can determine the tip resistance. So, this is the N is the standard penetration value, SPT value observed in field without overburden corrections. I have mentioned that few cases you have to apply the overburden correction, few are not. So, here overburden correction is not required without overburden correction, that N value. So, that is the length of the pile, this is the diameter of the pile. So, again this is limited to 400 N kilonewton per meter square. Similarly, the skin friction value we can determine by using these two equations, again for displacement or driven pile and for each pile. So, N average is the average N value along the length of the pile. So, for the displacement pile, it is limited to 100 kilonewton per meter square, and for each pile it is limited to 50 kilonewton per meter square. Similarly, IS code has also given equation by which we can determine the ultimate load carrying capacity of the pile by using SPT value. So, here this N is the average N value at the tip, and N bar is the average N value along the length of the pile or shaft of the pile. AS is the surface area of the shaft and AP is the base area of the pile. Okay. And this is for cohesionless soil, this equation, and for fine sand or plastic seal we can use this equation. Okay. These two are given. So, this QU is in kilonewton. Okay. And this QP for driven pile is, because first part is for the QP, second part is for the friction resistance part. First part is the tip resistance, second part is the friction resistance, and that first part it is limited to 400 N, N is the N value kilonewton per meter square. So, this way also we can determine the pile ultimate load carrying capacity. Similarly, for the board pile, because those equations are given for the driven piles. And so, for the board and cast in situ piles in sand, that QPU will be 1/3 of the QPU that we determine using the above or using the already discussed equations for driven pile, and friction resistance will be half of the friction resistance of the driven pile. But if it is a driven and cast in situ pile in sand, then if it is cased, then the QP and the FS that are taken for the driven pile you have to use for the driven in cast in situ pile also. and if it is cased. If it is uncased, then Fs will be Fs for driven pile and Fs will be Fs of board cast in situ pile. Okay, so, this is clear that if it is uncased, then Fs will be Fs of the driven pile, that Fs we will get from the previous equations. And here if the proper compaction of concrete is done, then Fs will be equal to the Fs of the driven pile. If the proper compaction of the concrete is not done, then we have to determine the board cast in pile situ cast in situ pile Fs, that will be Fs in this case. Okay. So, first one is the driven pile, then next one is the board pile. If the compaction is not done properly, then the board pile. If the compaction is done properly, then driven pile. Okay. So, these are the equations. Then now I will go for the group action of the pile. So, suppose we have a pile group of say 9 piles. Okay. So, this way we can determine the efficiency of the pile. So, first we have to determine the load carrying capacity of the pile group, considering there will be block failure. Block type of failure means the total pile group will fail. Okay. So, considering that, we will calculate the load carrying capacity of the pile group, and then we will calculate the individual load carrying capacity of the pile, and that we have to multiply with the number of piles. N is the number of piles. Now, that if the spacing between the piles are very large, then definitely the failure of the pile will be due to the individual pile failure, because there will be less group interaction or pile to pile interaction as the spacing is large. So, in such case the efficiency will be 1. Now, if the spacing is very small, then there will be a interaction between the pile to pile, and the pile influence zone, they will also overlap to each other. So, then our group load carrying capacity will reduce. So, in that case the efficiency of the pile will be less than 1. So, that means the spacing is large, efficiency will be 1, because that time the failure will be due to the failure of the single pile, and if the spacing is less, then there will be a group interaction and the efficiency will be less than 1. But there is a case the efficiency can be more than 1 also. So, if the driven pile is used for loose to medium sand. So, in such case what will happen, that due to during the driving of the pile, so if it is a loose sand, the sand will compact. Okay. So, because of that, this strength will increase. So, now for the group pile, as the pile will compact and there will be a increase of the strength of the pile. So, the group efficiency will increase. Okay. So, that increment will be more for the group, because here the soil will be in the confined condition. So, when you apply the for the driven pile, so the soil surrounding soils within the group, they will be compacted. So, there will be strength will increase. So, efficiency will increase. Okay. So, that means in such case as the single pile, that compaction effect will not be that significant. So, that means the load carrying capacity of the pile for single into the number of pile will be less in case of group pile condition or block failure condition, because in that case the total pile within the group or the total soil within the pile group, they will be compacted, there will be more compaction effect because of the surrounding piles, and the soils are within that zone. So, that means the soil strength in that group pile condition will be more. So, that means the density of the soil will increase due to the compaction. So, that means the group efficiency will increase. But generally design of the pile group, we do not consider the efficiency more than 1, even if it is more than 1, but we will limit that value up to 1. So, now we will calculate and the calculation of the group efficiency, as I mentioned that we have to calculate the pile based on the single pile failure and then for group or the block failure, and then you have to determine the efficiency. Or what would be the load carrying capacity of the pile? So, we will calculate the pile as a block failure, pile group load carrying capacity as the block failure and as a single pile failure, and then we calculate the block failure pile group capacity and the single pile load carrying capacity, then you have to multiply the number of piles. So, minimum of these two will be the load carrying capacity of the pile group. So, and now the next one is the settlement of the pile group in clay, because in the clay the settlement is very serious effect, and settlement we have to calculate in the clay soil, because as we have discussed the settlement is will significant effect in your design if the soil is clay. Okay, because in the sand, definitely sand also will have the significant effect if the soil condition is not good, but most of the cases settlement we calculate for the clay soil, because the clay soil it will take, there will be a consolidation settlement. So, the settlement we have to calculate specifically for the clay soil, but for the loose soil also you have to, loose sand also you have to calculate the settlement of the pile in sandy soil also, but clay soil the settlement is very crucial. So, now for this type of condition, when the pile is or the piles are installed in a homogeneous clay, then what we will do, we will consider this, all the piles are connected with a raft, okay, and that raft is placed at a depth of 2 by 3 L. L is the length of the pile, and then we will calculate the settlement of that raft, and I have already discussed how to calculate the settlement of the raft. Similar process we have to consider here, but only case that you have to place that raft at a 2/3 depth from the top of the pile, if it is a homogeneous clay. Then there will be 1:2 distribution, and then we will calculate the immediate settlement, then we will calculate the consolidation settlement, same as the pile, same as the raft design. So, now this is for consolidated settlement, which is same as the settlement of the pile raft, settlement of the raft in case of shallow foundation. Now, if the pile is resting in a stronger layer and the top layer is a very weak layer, then the raft we have to place at a depth of 2/3 from the top of the stronger layer. So, suppose this is a weaker layer, this is a stronger layer. If the strain difference is not that much significant, soil is a layered soil, but strain difference is not much significant, then we will consider it as a homogeneous soil. Because suppose if one layer it is very soft clay, which is say 30 or 25 kPa is the Cu value, and the bottom layer which is a very steep soil, say 200 kPa Cu value, then definitely we will consider this condition, and in that case the raft we have to place the 2/3 from the top of the bottom layer. And another one is that the pile is resting on a strong strata. I mean, this is a very strong strata where the pile is resting. So, in that case the raft we have to place at the base of the pile. Okay, so, this is a raft you have to place at the base of the pile if the pile is resting on a very strong strata, and then if the pile top layer is soft and the bottom layer is very steep and the strain difference is very significantly high, then in that case we have to place the raft at 2/3 from the top of the second layer or the stronger layer. So, now pile group settlement also we can determine based on the single pile load test data. Suppose if I know the single pile settlement, then based on the using these equations we can determine the pile group settlement also. So, this is the settlement of the pile group. We can determine SI is the settlement of a single pile and B is the width of the pile group, and this is the equation, and remember that we have to express B as meter. Okay. Similarly, this also we can determine by using the approach or the equation proposed by Meyerhof. This is the first one is proposed by the Skempton. And what is the B value? B value is the width of the pile block in case of group pile. So, that means, if this is S is the spacing between the pile and D is the diameter of the pile, and diameter of all the piles are same and spacing also same for all the directions or both the directions. So, that case B will be, this will be 2S plus half D this side and half D this side. So, this will be D plus 2 plus 2. So, that means it will be 2 S plus D. Okay, so, that will be the B, and similarly this side also this will be the B if it is a square pile. So, this way also we can determine the settlement of a pile. Now, I will solve one example problem. So, the same load settlement plot I have taken here, that I have used to calculate the load carrying capacity of the pile, single pile. Okay, so, that settlement the same load settlement curve I have used here. So, this is the load settlement curve. So, this is the load and this is the settlement. Okay. So, in previous case, in the previous problem, the same problem, the QU was for the single pile was 153 kilonewton, ultimate load carrying capacity of the pile, that is for single pile. Oh, sorry, that was the allowable load carrying capacity, because that is not the ultimate, that was the allowable load carrying capacity of the pile. So, based on this IS code recommendation, we have already determined what is the allowable load carrying capacity of the pile, and that value was 153 kilonewton. Okay. In this same load settlement plot we have already used to determine the allowable load carrying capacity of the pile, and that value was 153 kilonewton. So, now the settlement corresponding to 153 kilonewton, this is 40, 53 will be something like here. So, that settlement is will be 8 millimeter, is 8 millimeter from the chart. So, this is 120, 40, 53. So, this is 153 kilonewton and corresponding settlement is 8 millimeter. So, that means, under the 153 kilonewton load, which is the allowable load carrying capacity of the pile, the settlement is 8 millimeter, and that settlement is for the single pile. So, based on this data, we can determine the settlement of the group pile by using Skempton equation or the Meyerhof equation. So, I am using Skempton equation. So, S g by S I, that is equal to 4 B plus 2.7 divided by B, and B is in meter, 3.6 whole square. And the pile configuration or group configuration is given here. So, it is a square pile group where the spacing is 900 millimeter and diameter of the pile is 300 millimeter. So, diameter of the pile is 300 millimeter or 0.3 millimeter, but here now it is a group pile. So, spacing is 900 millimeter or 0.9 meter. So, here the B value will be, as I mentioned, that will be 2 into 0.9 plus 0.3 diameter. Okay. So, that will be 2.1. 2.1. So, now that value if I put in this equation, this will be, so directly I can write the settlement of group, that is equal to settlement of single pile into this value 4b plus 2.7 divided by 4 plus 3.6 whole square. Okay. So, the settlement of the single pile is 8 millimeter, 4 into B is 2.1 plus 2.7 divided by 2.1 plus 3.6 to the power square. So, this value is 30.3 millimeter. So, the settlement of the pile group is 30.3 millimeter, when the settlement of the single pile is 8 millimeter. So, this way we can calculate the settlement of the pile group also. So, in the next class I will show you a complete design of pile foundation in clay. That means, the how to calculate the pile group load carrying capacity, and then how to calculate the settlement of the pile in group, and I will solve one numerical problem, and then you will find that how, considering settlement as well as the load carrying capacity, we can design a pile group. Thank you.